दो पार्ट में कर देना अच्छा हो जाता है, जल्दी से हो जाता है. Today we shall study about transistor as an amplifier in semiconductor electronics chapter of modern phase part. To operate the transistor as an amplifier, it is necessary to fix its operating point somewhere in the middle of its active region. If we fix the value of VBB corresponding to a point in the middle of the linear part of the transfer curve, then DC base current IB would be constant. The DC voltage VCE or VCC minus ICRC would also remain constant. The operating values of VCE and IB determine the operating point of the amplifier as shown in the figure. If a small sinusoidal voltage with amplitude VO is superimposed on the DC base bias by connecting the source of that signal in series with VBB supply, then the base current will have sinusoidal variations superimposed on the value of IB. As a consequence, the collector current will also have sinusoidal variations superimposed on the value of IC, producing in turn corresponding change in the value of V0. We can measure the AC variations across the input and output terminals by blocking the DC voltages by large capacitor. In the description of the amplifier given above, we have not considered any AC signal. In general application, amplifiers are used to amplify alternating signals. Now let us superimpose an AC input signal VI to be amplified on the bias VBB DC as shown in figure 1. The output is taken between the collector and the general and the ground. The working of an amplifier can be easily understood if we first assume that Vi is not equal to 0. Then applying Kirchhoff's law to the output loop, we get VCC equals VCE plus ICRL. Likewise, the input loop gives VBB equals VBE plus IBRB. When Vi is not 0, we get VBE plus Vi equals VBE plus IBRB plus del IB into RB plus RI. The change in VBE can be related to the input resistance Ri and the change in IB. So Vi equals del IB into RB plus Ri equals R delta IB. The change in IB causes a change in IC. We define a parameter beta AC, which is similar to beta AC. Beta AC बराबर डेल्टा IC बटा डेल्टा IB और IC बटा IB, which is also known as the AC current gain AI. Usually beta AC is also to beta AC in the linear region of the output characteristics. The change in IC due to change in IB causes a change in VCE and the voltage drop across the resistor RL because VCC is fixed. So, delta VCC बराबर delta VCE plus RL delta IC बराबर 0 or delta VCE बराबर minus RL delta IC. The change in VCE is the output voltage V0. So, by V0 बराबर delta VCE बराबर minus beta AC RL delta IB, the voltage gain the amplifier is AC बराबर VO बटा VI बराबर delta VCE बटा delta R delta IB बराबर minus beta AC into RL बटा R. The negative sign represents the output voltage is opposite with phase with the input voltage. Therefore, the power gain AB can be expressed as the product of the current gain and voltage gain. So, AB barabar beta AC cross AB. So, beta AC and AB are greater than 1. We get AC power gain. However, it should be realized that a transistor is not a power generating device. The energy for the higher AC power at the output is supplied by the battery. Mm-hmm.